everyone. Welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Kevin, who has completed one of our courses, ROS 2 Basics, in 5 days. And at the end of this course, you can you can do a project in order to get our certificate. And this project is actually done on a real robot here at our offices to showcase what they've learned in these courses that we offer. So, hello, Kevin. How are you?
Hello, I'm good. How are you?
I'm good, thank you. So, whenever you want, we're excited to see your project. Whenever you want, you can share your screen and just tell
Mhm.
us how you've done your project.
Okay,
Great.
absolutely. Okay, can you guys see my screen now?
Yes, we can see the screen. We can see the robot and the terminal.
All right. So let me just start the robot running through the wall first,
Mm-hmm.
right? So here is we start finding the wall.
So the robot is trying to find the wall?
Yes, so it's find the wall. You see it's facing
Oh, yeah, it's
basically
twisting,
facing the wall
yes.
right now. Then we'll move toward the wall until it reaches like 30 centimeter.
Uh-huh.
Then we'll start aligning the right side to its right side to the wall before it
Okay.
start the work following. Okay. Okay. So now it start the work following.
All right. Cool. And is there any information you're receiving about this program?
So
There we go. Yeah, that's what I wanted.
yeah, so right now it's we recording the distance it travel and also the distance from the origin,
Ah, I see.
the place where it started. Also it's also receive data from the sensor about uh the distance from the front and the right side.
I see. So then your project is then divided in 3 parts: finding the wall,
Mhm.
going around the wall, and recording how much you've traveled.
Yes.
Nice. Great. So it's like halfway there. And
Mhm.
what should we expect once the robot finishes that lab?
Uh, so when the rock is within 5 centimeters from where it starts, it should stop.
It should stop. Okay.
Yes. So you see it's around 1 meter left.
I see. Yeah.
Yeah.
And you're obtaining that through odometry, I'm assuming.
Yes.
Nice. Very smooth movement. Very nice.
Yeah, thank you. Ooh.
So it looks like now it's getting
Yeah.
away from it.
Oh. Uh. Yeah. So sometimes it kind of miss
Yeah, I see what you're
the
saying.
5 centimeter.
Before you kill it, I have an idea. Why don't
Mm-hmm.
we? Uh, this is the demonstration part of the presentation. So why don't we just leave this running, and why?
Okay.
And you can just explain us how you solved each part, and maybe while it's running, it will eventually hit that spot. And if it doesn't, I know it's just increasing the size, and it will hit it.
Yeah.
Yes. So please tell us how you've done each one of these sections.
So I can just share my code
Yeah, great.
if that's possible. Okay.
Perfect.
So the first part is probably the creating the service to find the wall.
Uh-huh.
So first I create a server right here, and then I will have to a publisher to publish the information uh about the service, and so the subscriber to the LiDAR sensor. So the subscriber will update the this the sensor reading from the front and from the right side.
Mm-hmm.
And then after that, we'll calculate the angle, how much the angle to rotate in order to either face in the wall or to align the right side to the wall.
Mm.
So here is some uh, technique to reduce the angles. Say got over 180 degrees, you can decrease it so it can turn the other way, so it make the turn smaller.
Mm-hmm.
Okay, so here just when it receive the call from the client, so that's where it start fighting the wall. So when it execute the first turn, so this is where it find the the direction where it has the minimum distance to the wall, and then it will turn until it's facing that direction. So after that, we will publish some message uh, to the client, and then we start moving toward the wall.
Mm.
Yep. So here it just a while loop, so it's repeated until it's around 30 meters to the wall. So after that, we start aligning the right side to the wall. So this one is very similar to the first one. The only difference is the angle to rotate here will based on the right side of the wall, not the front, not the
Mm-hmm.
front of the robot. Yes, and after that, the service is complete, and we will unsubscribe to the sensor and return back to the client. So this is where the main thing happened. The service client is right here. It's created right here. And, and after we start robot, it will first uh, where is it? Yeah, so it will send the oh yeah, send request to the service right here. Okay. So after that,
Mm-hmm.
it will start following the wall. So after it's complete, finding the wall, it will start moving. So here is how it's moved. So it's constantly read the sensor to obtain the distance from the wall at the front of the robot and at the right side.
Mm-hmm.
So if the front is more than 50 centimeter, it means it can continue to go straight. So here just some uh, adjustment so that it can maintain uh, the distance around 30 meter to the wall. So if uh, when the distance in front of the robot is less than 50 centimeter, it will start to turn to the left.
Mm.
Yeah, it will turn until the distance is
The
larger than
front.
50
Uh-huh.
centimeter. Yeah.
Nice.
Okay. And here is the uh, action to record the odometry.
Mm-hmm.
So if you create the action server, they have a subscription to the odometry. So every time, I think every second, it will call back and obtain the position.
Mm-hmm.
So from the position here, it can so we will append to the list of for the record.
Right.
Yeah, and from the record, we'll calculate the distance travel. So this is how it get the distance travel using some algebra,
Mm-hmm.
geometry. Yeah, so we record it and we'll put it into send the feedback back to the client.
And where is that condition you mentioned that it hasn't been accomplished yet? That we see
Oh,
the
yes, right here,
robot.
this one.
Ah,
So
I
yeah,
see.
so because I think you see this part here. with
Right.
hardware tuning everything. So sometimes it's not really kind of wobbling.
Yeah,
So that's why,
because maybe because of the way it's turning, it won't
yeah.
reach that
So
5 centimeter radius you're ascribing there.
yeah, so sometimes if you see right here, I think it kind of overturn, underturn, and in this case, underturn.
I
So
see.
turn, yeah.
That with the addition of the odometry having an intrinsic drift, that as if you run it for longer and longer, you will have a
Hmm.
bigger and bigger difference. So I
Yeah.
understand that. This is an error of mine that I don't say 15 centimeters instead of 5, right? Because that will get rid
Yeah, I
of
think
so
five a little
many
bit too.
issues, and
Yeah.
it's not the point of the exercise. Um, so at the end, it returns the result. That's the only thing I kind of want to see, you know?
Hmm.
So maybe if we can uh, change that to 25, let's say, and just run it again while I ask you the questions and wait for that return to happen. Yeah?
Okay. Let me just kill this.
Nice. I like how you only compile the package you are editing. Great.
Yeah, it saves a lot of time.
Very nice. So yeah, let's just launch
Mm,
it and just wait for a while.
hopefully it's worth itself.
It's twisting. So great, awesome. So let me go ahead and while this is going on, I'm just
Mhm.
gonna ask you some questions I thought about the project. Really nice presentation, really
Oh,
short
thank
and
you.
to the point. It showcased that you know what you're doing and that you actually went through these steps to complete the project. So congratulations, Kevin. Really, really nicely done.
Oh,
Um,
thank you.
I really liked, for what I saw a little bit, I like how you structured your code very nicely. I like that you know wait for the service response before you start your wall following, and then
Hmm.
you use these tools that ROS provides to keep going. Really nice use of constants. For example, I saw you're using constants correctly, you know, mentioned with all caps underscore. So that's really nice. And a couple of questions I have. It's the
Hmm.
first one is I noticed a constant that I think it was 999, and it was related to a laser index. I just wanted to know what
Oh,
that is. Just curious.
uh, let me remember where it is.
I think it might be in the wall following node. Or this one. Yeah, I don't know which one.
Oh, yeah,
This
this
one.
one. So I
Yes.
had to wait for, so before you can start the wall finding service, you have to wait for the sensor to be read first.
Ah, I see. I
That's why
see.
it's 999.
Ah, okay,
That's
okay,
the
okay.
maximum you can have is 720. Oh, no, 719.
Right. Okay.
Yeah.
Okay, fine. That's great. And then the other thing I wanted to ask you, if because this is a point of misunderstandings and
Hmm.
errors for a lot of people that are starting with ROS2 and Python specifically here, is could you explain a little bit how you did the callback groups multi-threaded executor implementation, right?
Okay. So the callback group, this one?
Yeah, exactly. So I see that
Okay.
you created this group and then you ran the nodes with some threads. Could you just explain your process there and why
Yeah,
you had to do that?
because for example, in this wall folder, you need to run a service, a subscriber, and a publisher. So because you cannot run two threads at a time, so you have to use this re-entrant group.
Mm-hmm.
So you can run multi-thread.
Right, and then you
Uh,
add your callbacks to that
mhm.
group.
Yes.
Doesn't have to
So
be. Does it have to be a different group?
uh,
No, right there, you put it
yeah.
in the same group. And just as a comment here, the
Hmm.
publisher I didn't know you could actually add it to a callback group because it
Oh,
doesn't have an intrinsic callback, right? A subscriber will have a callback every time a message arrives, and that one you can pull it. Oh, great. I didn't
yeah,
even know that. My point is, it would work without you adding the publisher
yeah,
to a
that's right.
callback group. And then you run these callback groups in different, these callback in it, this node in a different threads, so you
Mm-hmm.
that can take in the value. Great, awesome. And lastly, I just see that the robot stopped. So
Oh, yeah.
that means the condition was broken. So we should see
Mm-hmm.
a result, correct?
Uh,
So in your there we go. So
oh,
an
yeah.
action completed. Um, so is there any feedback to this action that you called?
Uh, I think the feedback I have the mostly that odometry distance.
Absolutely. Yes, that is your feedback of your action
Mm-hmm.
is the distance that you've been traveling. All right, Kevin. Um, very nice. Very. I just want to congratulate you again. And yeah, I mean, pretty nicely, well to the point, and you accomplished each section. So congratulations, Kevin.
Thank you.
All right. Awesome. 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 So that's it for us, guys. So let me just come back here to my screen. So, yes, uh, great. Again, congratulations, Kevin. And I just want to mention for everyone else that is watching, this is your opportunity to do what Kevin did here and uh, complete the project in order to get your certificate with us for our courses and to showcase the learnings you've had from our course. So I encourage everyone else to do what Kevin did here. And that's it for us, guys. Again, Kevin, one more time, thank you, and we'll see you for the next time.
Thank you so much.
All right. Bye bye, everyone.
Bye bye. You have a good day.
You too.